Welcome again, everybody. My name is Matt Medali, solution architect based out of Texas, here with Megaport. Just a little about me. I was formerly with a customer. In my last role, I was with a customer, and I was the one that set up Megaport. So I have a great insight from both sides of the aisle, from the operational standpoint, how to live and work with a Megaport. So I've been using it since 2018, but I've been on board with Megaport for last 2 years or so. So I'm very excited to be here. Let me just break down kind of what we're what we do and give you, the high level, and then I have a specific use case I wanted to walk you guys through. So here at Megaport, we consider ourselves the hyperscaler network connectivity on demand. That means, if you needed to connect to any of the clouds, everything is pay for what you use, it's point and click, and it's secure on our private backbone. And when I say any of the clouds, I really mean all the big ones that are worth connecting to. So AWS, GCP, Azure. Who we serve is currently just over 2,500 enterprise customers. We have more on-ramps than anybody. So, globally with Azure, we're probably number one. With AWS, we're number two. Uh, we're also data center agnostic. Um, so what that means is we have over 100 different data center operators that we support. We currently, breaking news too, we just announced that we reached 1,000 data centers, which is a huge milestone for us and the team. And then we also have a Megaport marketplace where customers can connect with other Megaport customers privately across the backbone. One of the best ways to explain what we are is when we talk about what we're not. So we're in the middle mile from the colo data centers. Um, we're not the last mile. So if you're not in a colo, you'll want to get like a private circuit to extend a link to the nearest Megaport uh, data center. And then from there, you would go um, to any of your other, that's where you connect to the clouds, connect to other providers. We also have an internet exchange. So we're what's known as the middle mile. So uh, sorry, I'm trying to. I did the annotating, and there we go. Um, just to give you an idea of what a Megaport connected network looks like, we'll start with, let's say, pulling a port in Dallas at Cyrus One, and you wanted to connect to AWS on-ramping in Dallas as well. We normally recommend you on-ramp to the nearest physical on on-ramp to where your colo is located. So what that does is kind of minimize your Megaport costs, and then you would ride the cloud's backbone to wherever you are. So in this case, AWS. And let's say you also had a data center in Atlanta and one in Chicago with Equinix, and you also wanted to connect to different clouds there. Totally fine, a very standard use case. If you wanted to take things a step further, you could also use your ports, your megaports, to connect your data centers for a DCI or data center interconnect. So each port can do up to 100 different VLANs or virtual cross connects, VXCs. And so the same port that you use to connect to your clouds, you can also connect your other ports, or you can connect any other networking devices, which we're going to go to next. So let's say you had your application in AWS and a database in Oracle. You can use the Megaport Cloud Router or MCR to connect your two clouds without having to hairpin traffic back to on-prem. Or if you didn't have an on-prem, you were just cloud only, this is also a great fit for that. So if effectively, you put your workloads in the clouds that work best, and then use Megaport to kind of connect them both privately together. And then, the last part of our access products would be our enabling the branch offices through SD-WAN or like a next generation firewall. So that's through our Megaport Virtual Edge or MVE. So on the MVE side, you would have all the major vendors that we would support. Think of it like a limited bare metal, where it's a curated sort of platform where we have certain images that are fully supported. You just click a button and deploy them. These virtual devices, they look and feel just like any other virtual device on your network. So on the SD-WAN side, Aruba, Cisco, Fortinet, on a router, you could do a virtual router like the Cisco AKV, or firewalls. We support Fortinet, FortiGates, or Palo Alto. So the important thing to note is on the MVE, we provide the compute, the networking, and the internet. You have to bring your license. Whereas, compare that to the MCR. The MCR is a full stack router that includes licensing, and it's fully managed in the Megaport portal. So um, that's kind of the highlight of all of our products. What I'm going to do is dive into our little use case here and kind of give you a topology. I need to find some way to get off this annotation. Uh, there we go. So here's um here's a quick drawing that I did uh, on this use case. Sort of have a global backbone. So one of the cool things about our platform is the flexibility and scalability. We can pretty much use this to tailor uh, our solution to any use case. In this situation, we have a global WAN scenario, and customer is very advanced. They're service chaining our devices, so we have an MCR at the cloud layer, and then service chaining to an MVE running Aruba, which has the SD-WAN, and it's distributed globally so that you can optimize performance. So, if you had a store or a branch office in California, instead of going and connecting in US East, you connect in US West. Likewise, if you had a place in Amsterdam or somewhere in Europe, you connect locally to Amsterdam instead of going all the way to US East. So we have such a great presence worldwide now, 1,000 data centers, that it makes things very easy to accommodate. We also have Brazil. So in this case, customer has like their main uh, data centers in U.S. Central, and they wanted to turn up hubs in the West and the East, and then have like a backbone for all of their connectivity. So all of these sites are connected. The the problem is certain clouds have different limitations. In this case, they have thousands of stores, and on Amazon specifically for Direct Connect, there's a limit on how many prefixes you can advertise to them. It's a arbitrary limit that AWS sets up. Typically, it's 100. I think, in some use cases they'll allow you to do a little bit more, but that's very rare. So what we're going to solve for is how can we minimize the route advertisements to AWS, but still maintain all of the routing for all of our other sites that don't have that limitation, as well as, having all of your other routes available to your SD-WAN. So what I did was I set up sort of a lab environment with a couple of MCRs to simulate um, some of the routing availability. So we're going to start from this core MCR, and I'm going to take you to the portal and deploy this so you can see what that looks like. Well, technically, I've already done most of it. I'll show you what the setup looks like. But I have a core MCR that has all the routes, and then I have another MCR set up to kind of play the role of AWS. So the goal is to, we have all of these routes here, and we want to try to minimize that to just one summary route and, um, still maintain on this other MCR, which I'm going to call it test, that still has all of these guys here. So, basically we can establish that, yes, we're only limiting a subnet here, but the other the other points of presence would still have all the other routes. So let's see here. Uh, Let me click on our portal. Here's our Megaport portal, and when you first log in, you'll get a dashboard like this. And effectively, this is all of our points of presence. So you can have a geographical representation of where everything's located. So like in my previous example, the customer would have the full network relayed here, so you have an idea where things are located. In this case, since I'm in Texas, everything's built out here in Dallas. There we go. So let's click on the services tab. This is the same view, but it's in a list format. On the upper left, you have your access products. So you have the port, the MCR, and the MVE. And remember, we're working at this from the MCR layer. So the Megaport Cloud Router, as I mentioned, it's full stack router, includes the routing. I'm sorry, includes the licensing. Of course, it does routing. You can do BGP on it. Has all the features like ASPAT prepending. You can do prefix lists. So that's kind of where we're going to be looking into. So I'm going to create an MCR just to show you how quick it can be spun up. And let's do this one in Dallas as well. We'll do Carrollton. I'm going to call this Megaport Live. Um, just like any of our other services, everything on a pricing standpoint is very transparent. So if you wanted to do month to month, it's just over $500, and down to 10 gigs. So just understand that the more the bandwidth, the more the cost, of course. And then the longer the term, the cheaper it gets. Simple enough, right? So the only attribute you need to start off with is your ASN. I'm just going to put in 65,000, and we're going to add this guy. So it's as simple as that. This is going to be deployed on our edge. It's spinning up with dedicated resources. We have diversity zones, red and blue zones, and what that signifies is, within a metro, whenever we're doing scheduled maintenance, software upgrades, that sort of thing, we would only take one zone down at a time, and you would have plenty of notice, of course. But the way to kind of make sure everything is deployed as best practices, you would have at least two MCRs in the different zones. And that's kind of what I signified here. In this design, you have a red zone and a blue zone for your stack. And then likewise, on your on-ramps, so the connections to the clouds, you would have red on-ramps and blue on-ramps as well. So that way, in the event or when we schedule the maintenance, you can be assured that at least one of your connections should be good to go. So let's go through here a summary. This is our MCRs that I've already deployed. This is kind of our core MCR. And then we have our um, MCR that's playing the part of AWS. And then this is our test. And the way you can validate all of this, it's green. And we also have this handy dandy icon that pops up, shows you, if BGP is up or not. And you can also, and that's on the VXCs. So this is the MCR level, and these are the virtual cross connects or VXCs. So as they're connected, you can see. So this one is connecting MCR 1 to 2. This one is connecting 2 to 4 or to test. This one is connecting the core to AWS. As we round out this tour, the other way to kind of manage your routers is take a look through the looking glass to see what routes you're learning. So you can see here, this is on MCR2, and we have BGP established with all the other MCRs, and these are all the routes we're learning. So we have a total of 7 routes, and you can dial in. So this is my core, this is the AWS router. So I can see I'm advertising 7 routes. I've only received 1 route from them. All right. And then you can also, using this same um, field, you can switch between your MCRs to look at their routing table. So going to the AWS router, we can see that we have all 7 routes that we're learning. So let's go ahead. We're going to build a prefix list filter, and then we're going to apply that on the BGP session with the AWS router. So let's go to our MCR. So prefix lists are built at the MCR level. So this is where you would apply it. We can also do packet filtering now, or like an ACL. So we're going to create a new list, and we call it allow 10.8. And we're going to call it match 10.0.0.0/8. Save. So we've created that list. Now all we have to do is apply it. So we're going to go back to the services tab. And we can do it in 2 different locations. We can either do it here on the VXC that's facing AWS, or you can do it here because the VXC kind of is the same on both sides. So let's do it here. So on the and this is the interface, I guess, of the management of the router. You have your route here, and you're focusing on this side, and then this is the A end is MCR 2, the core MCR. The B end is going to be on the other router, and so you can apply the prefix list on from where it says BGP connection. So we have, this is our local IP, this is our peer IP. We're going to click edit, filters, and because we're trying to export, we're going to do a permit list and select the allow. So basically we're exporting only whatever's on this list, and then there's a explicit deny at the end of that. So we're going to click update, click save, and as you can see, some changes can take up to 2 minutes to appear. Should have a thing in the logs. Yes, not. I think it just does the neighborship. So let's give that a second. Let's go back though. You can see that Megaport Live MCR that we spun up is already green and ready to go. And so you can build your connections to any of the clouds that way, or you can connect any of your existing MCRs. Very, very easy to do on demand. So let's see what we see here. We'll click on this. So we're still seeing the routes there. Yeah. Now we just see two. So we have the 10.8, and then this is a connected route. So we were able to filter that connection only. And then now let's take a look at our test router and make sure that we're still seeing all the routes there. Yep, so we're still seeing all 7 routes. So that's pretty much it. That's all I was planning to talk to today. Um, yeah, so we took a look at Megaport, all of our access products, the port, the MCR, the MVE. Gave you an example of a real situation running out in the wild where a customer had an issue with the limitation of prefixes being advertised to AWS. So we built up a lab. We applied a prefix list filter and was able to limit, the prefixes being advertised to one peer while still allowing the rest of the prefixes on, to your other peers. But that's it. Any questions?
No questions today.
Well, thank you very much, guys. Have a great rest of your day and a great weekend.